So angle of deviation we have seen. Now a relation between angle of minimum deviation and refractive index of prism. If angle of incidence or emergence are very small, means prism is thin. So for thin prism, I am going to see relation between angle of deviation and a refractive index. Suppose this is a thin prism. Angle of prism is A, and generally it is less than 10 degree. Then we say it is a thin prism. When angle of prism is less than 10 degree, we used to say it is a thin prism. Now, if angle of incidence is very small, means incidence is approximately normal. Emergence is also very small. Then applying Snell's law at point 1. Applying Snell's law at point 1, I have to write 1 into sin I is equal to mu into sin R1. Angles are small, so sin I can be written as I, and sin R1 can be written as R1. So this is a relation we got from refraction at point 1. Now refraction at point 2, it is mu into sin R2 is equal to 1 into sin E, as angles are small, so it is mu R2 is equal to E. So E is equal to mu R2, and I is equal to mu R1. Now we know angle of deviation I plus E minus A, so it is mu R1 plus mu R2 minus A. Putting value of I of equation 1 from equation 1 here, and putting value of E from equation 2 here, so I got this. Now take mu common, R1 plus R2 minus A, and we know that R1 plus R2 is A. So it is mu minus 1 into A. This is angle of deviation and refractive index of prism, angle of prism. This is a relation when prism is thin and angle of incidence, angle of refractions are small. Then this is the relation, important relation, you should remember this. So let us see one question on this. Question: suppose it is given that angle of prism is 5 degree. Refractive index is 1.5. Then find angle of deviation. And prism is thin, angle of incidence and emergence is very small. Means in case of thin prism you have to find angle of deviation. So formula is mu minus 1 into A. So it is 3 by 2 minus 1 into A, that is 1.5 minus 1 into 5 degree. So it is 0.5 into 5 degree. So 2.5 degree. So this will be angle of deviation in this case. So for thin prism, angle of deviation is mu minus 1 into A. Now you know there are two angle of incidence for which angle of deviation is same. There are two angle of incidence for which angle of deviation is same. Now see condition 1. Suppose this is a prism. A ray incident this is normal N1, this is normal N2, and this is angle of emergence. This is total deviation. So here total deviation is I plus E minus A, means angle of incidence is I, angle of emergence is E, and A is angle of prism, you know. Now if I make E as angle of incidence, I know that if I put a plane mirror so that this ray fall perpendicular on this, then ray will retrace its path, means this angle of emergence now becomes angle of incidence, and this angle of incidence now becomes angle of emergence. So from principle of reversibility, if emergent ray is reflected back like this. Suppose I put a plane mirror here. This is normal here, and this is normal at the surface. This mirror will reflect light, so now this light will go like this, and it follow the path like this. So if I say reflected ray, it is behaving like incident ray. So this becomes angle of incidence, and that is equal to angle of emergence. And now this reflected ray is behaving here like emergent ray. So this angle is equal to angle of emergence, and that is also angle of incidence in first case. So when this ray is reflected back, angle of emergence, angle of emergence becomes angle of incidence, and angle of incidence becomes angle of emergence. And deviation remains the same, because now it is E, that is angle of incidence, plus I, that is angle of emergence, minus I. So if you compare deviation in first case and deviation in second case, you will find same. So on comparing these two, on comparing delta 1 is equal to delta 2, it means one angle of incidence is equal to I, angle of emergence is E. When angle of incidence is equal to E, angle of emergence is equal to I, and in both cases angle of deviation remains the same. So we have got two angle of incidence at which, suppose here I is 20 degree and this is suppose 40 degree. Then when angle of incidence is 20 degree, emergence will be 40 degree, and when angle of incidence will be 40 degree, emergence will be 20 degree. In both cases you are going to get same angle of deviation, because here if this is angle of incidence in second case and it is 40 degree, this is angle of emergence in second case, this is 20 degree. Now you see in both cases angle of deviation is same. It means we have got two angle of incidence for which angle of deviation is same. Now we can prove this by doing experiment. So experimental demonstration. When graph is drawn between angle of incidence and angle of deviation, this is angle of incidence and this is angle of deviation. It is found that when angle of incidence increases from minimum value, certain minimum value, angle of deviation first start decreasing, becomes minimum, and then start increasing. And this graph is not parabolic. The symmetry, the graph on right side and left side are not same. This side slope is lesser than this side. So this is the minimum deviation. Minimum deviation. Now for any deviation, suppose this is deviation delta. This is deviation delta. We have angle of incidence equal to this much. This is I1, at which angle of deviation is delta, and there is another angle I2, at which angle of deviation is delta. So there are two angle of incidence at which angle of deviation is same. At I1 angle of deviation is delta, and at angle of incidence I2 angle of deviation is delta. So in this case, if angle of incidence is equal to I1, then angle of emergence is equal to I2. In this case, angle of incidence is equal to I2, then angle of emergence will be equal to I1. So if angle of incidence is this, then angle of emergence will be this. And in both cases, if angle of incidence is this, angle of emergence is this. If angle of incidence is this, angle of emergence will be this, and hence angle of deviation will remain same in both the cases. And that is what shown in the graph. But what about for this deviation? Here it is only one deviation, only one angle of incidence. So at minimum deviation, angle of incidence is equal to angle of emergence. Here angle of incidence is I1, angle of emergence is I2. Both angles are different. But here angle of incidence is equal to angle of emergence. So when angle of incidence becomes equal to angle of emergence, deviation becomes minimum. So what we come to know from this experiment, first point, as angle of incidence increases, angle of deviation first decreases, becomes minimum, and then increases. Angle of deviation first decreases, then becomes minimum, and then increases. But this graph between angle of deviation and angle of incidence is not parabolic. Graph is not parabolic, means it is not symmetric about this point. This side graph is not same as this side graph, so it is not a parabolic graph. Remember this point. Second, for a deviation angle, there are two angle of incidence possible. For a angle of deviation, there are two angle of incidence possible. Third, at minimum deviation, angle of incidence is equal to angle of emergence. So these 3 points you should remember, and note the graph, slope of graph is not same on both the side. If you see this graph, left half graph, right half graph. It has lesser slope, means it is flatter graph and it is more steeper. So this side graph is more steeper, this side graph is less steeper. Less steeper, more steeper. So to get same change in angle of deviation, suppose you want to change angle of deviation delta here this much, then you have to change angle of incidence this much on this side. But for same change in angle of deviation, you have to change this much angle of incidence on this side. Let it be I prime. So delta I prime is more than delta I, means if your angle of incidence is lesser than angle of incidence corresponding to minimum deviation. If your angle of incidence is lesser than angle of incidence corresponding to minimum deviation, then a small change in angle of incidence will produce large change in angle of deviation, as compared if your angle of incidence is greater than angle of incidence corresponding to minimum deviation. Means if your angle of incidence is smaller than this, then by a small change in angle of incidence you will get large change in angle of deviation. But if your angle of incidence is greater than I naught, then you have to do large change in angle of deviation. You have to do large change in angle of incidence in order to get same change in angle of deviation as here. So remember this point. So here I am writing graph is not symmetric. Graph is not symmetric, graph is not parabolic, so remember this thing. Condition for minimum deviation. Now first condition, you know that I is equal to E. Deviation is minimum when I is equal to E. Now second condition, C. Let refractive index be this, angle of incidence be I, angle of emergence E, and that is also equal to I. This is angle R1, this is angle R2. So if I use Snell's law here at point 1, what I have to write? 1 into sine I is equal to mu into sine R1. It means sine I is equal to mu sine R1. Now if I use Snell's law here, then I have to write it like this: mu sine R2 is equal to 1 sine E, mu sine R2 is equal to 1 sine, at place of E we can write I because E is equal to I. So sine I is equal to mu sine R2. Now if you compare equation 1 and equation 2, see left hand side is same, so right hand side should be same. It means what I can write? I can write mu sine R1 is equal to mu sine R2. Mu cancel. It means sine R1 equal to sine R2, hence R1 is equal to R2. So second condition is R1 is equal to R2. This is second condition. So if R1 equal to R2, I will be equal to E and deviation will be minimum. Now third case, in case of equilateral prism, and or isosceles prism, that is all three sides are equal, this is called equilateral prism, or two sides are equal, this side and this sides are equal, A, B, C. Here AB is equal to AC. This is isosceles triangle. So this angle will be equal to this angle, and this is angle of prism, let it be A. Here also this angle will be equal to this angle, will be equal to this angle, and this is angle of prism. So whenever these two angles are equal, then in case of minimum deviation, the ray which is passing through prism, this ray between P point and Q point, this is called a refracted ray. It will be parallel to base of prism. This is base of prism. In this case also, a refracted ray will be parallel to base of prism. This PQ is a refracted ray and this is base of prism. So in case of equilateral prism and isosceles prism, a refracted ray that is PQ, ray PQ is parallel to base of prism. But this third condition is valid only if this condition is satisfied. And normally the prism we take, these conditions are satisfied. So until unless said, we assume that this condition is satisfied. If it is asked that this must be parallel to base, then this is not true, because it is true only if this condition or this condition is satisfied. In case of minimum deviation, this may not be parallel to this, but that question haven't asked till date. Whenever a prism is in minimum deviation position, this was parallel to base till date, whatever question that is being asked. So remember this thing. Now deviation in prism we have seen in first class that deviation occurs at both the surfaces. This is first refracting surface, angle of incidence, let this is R1, and here I am taking minimum deviation position, that's why R1 will be equal to R2. This is R2 and this is angle of emergence E. So some deviation has taken place at first refraction, let it be delta 1, and some deviation has taken at second surface, let it be delta 2. So total deviation we find by finding delta 1, that is I minus R1, and by finding delta 2, that is E minus R2. That's what we used to do. So deviation produce here, deviation produce here, and in this case both are clockwise, so we add these two to get total deviation. Now in case of minimum deviation, you know R1 is equal to R2. So in minimum deviation, R1 is equal to R2, therefore delta 1 is equal to delta, hence total deviation is equal to 2 times deviation produced by the one refraction. This is deviation produced here or deviation produced here. Now if I cut this prism, from middle, from here, if I cut, this ray is parallel to this and I have cut it like this. So this is perpendicular to this line. It means this first half the prism looks like this and second half is removed. The second half is removed. Now this is angle of incidence, this is normal, and it is kept in minimum deviation position. So this ray will be perpendicular to this, means angle of incidence here will be 0, so angle of refraction will be 0, so it will go like this. So no deviation produced by this second surface. Total deviation in this case is equal to deviation produced at first surface. So total deviation will be equal to delta. It means in this case total deviation delta prime is equal to delta, and you know delta is equal to total deviation in this case by 2. So delta prime total is equal to delta by 2. Delta total in that case by 2. It means if I cut half part of the prism and remove it, then deviation remains half of the earlier value of division. Right? You understand? So remember this thing. Now prism formula. Prism formula. It is relation between a refractive index, minimum deviation and angle of prism. It is a relation between refractive index, minimum deviation and angle of prism. Suppose this is a prism in minimum deviation position. So this angle will be angle of refraction, this is angle of incidence, and this is angle of emergence. This is also R. R1 will be equal to R2. Now if I use Snell's law here, I can write 1 into sin I is equal to mu into sin R. It means sin I is equal to mu sin R. This is equation 1. Now we know that minimum deviation is equal to I. At place of E we can write I, because I is equal to E. In case of minimum deviation, I is equal to E. So I plus E minus A. Minimum deviation plus A is 2 angle of incidence. So angle of incidence is angle of minimum deviation plus A by 2. This is I. And we also know that A equal to R1 plus R2. Here R1, R2 are equal, let they be R. So R will be equal to A by 2. Now putting value of I and R in this equation 1, I can write sine at place of I, minimum deviation plus A by 2 is equal to mu, and this is refractive index of prism material with respect to surrounding. So I am writing it is refractive index of prism material with respect to surrounding. Into sine at place of R we can write A by 2. How this come, you know? Now if you are confused how this come, you may write here refractive index of surrounding and refractive index of prism. Refractive index of surrounding, refractive index of prism. Refractive index of surrounding and refractive index of prism. I can write like this. So from here, if I want to write mu of prism upon mu of surrounding, that will be equal to sine minimum deviation plus A by 2 whole divided by sine A by 2. Now you know refractive index of prism material upon refractive index of surrounding medium. This is called refractive index of prism material with respect to surrounding. So it is sine minimum deviation plus A by 2 divided by sine A by 2. So this is prism formula. If prism is kept in air, then this become 1, this become refractive index of prism material. Otherwise, remember this is the formula.